FastMCP 3 implements a provider-based architecture for modular application composition, where FastMCP app instances encapsulate both UI entry points and backend tools within a unified namespace. The framework's provider system enables hierarchical tool registration and automatic visibility management, ensuring stable tool references across composition boundaries. We will examine how providers are initialized and registered with the core server, exploring the two available patterns for provider integration and their functional equivalents in the runtime system. The code demonstrates provider instantiation through both constructor injection and post-construction registration, revealing the framework's flexible composition model.
From FastMCP, import FastMCP. FastMCP app. App equals FastMCP app contacts. Add app UI. Def contact manager prefab app. Add app tool. Def save contact name. SDR email. SDR dict. Hash option 1 providers list. MCP equals FastMCP platform. Providers equals app. Hash option 2 add provider. MCP equals FastMCP platform. MCP add provider app.
This code demonstrates how FastMCP manages providers through the FastMCP app class, which encapsulates UI and backend tools into a single provider unit. The FastMCP app instance, app, is registered with a FastMCP server either during initialization, via the providers list, or dynamically using add provider. This modular approach allows multiple apps to coexist on the same server without naming conflicts, as each app's backend tools receive globally stable identifiers. The @app UI decorator marks entry point tools that return a prefab app UI visible only to the model by default. Meanwhile, @app tool defines backend tools that the UI calls via call tool, with visibility restricted to the app unless explicitly exposed to the model. This separation ensures clean tool management, where the model interacts with entry points while the UI handles backend operations. The call tool function bridges these layers, accepting either tool names or direct function references for composition safety. The design prioritizes maintainability and scalability. By using FastMCP app, developers avoid hard-coding tool names in call tool, which prevents breakage when servers are mounted under namespaces. The provider pattern also simplifies dependency management, as apps can be added or removed from the server without modifying individual tool registrations. This architecture is particularly useful for large applications where tools might be distributed across multiple providers. Let's break it down.
From FastMCP, import FastMCP. FastMCP app.
Imports the FastMCP class and FastMCP app class from the FastMCP module, providing access to FastMCP3's core functionality for implementing Model Context Protocol MCP servers and applications.
App equals FastMCP app contacts.
Creates an instance of FastMCP app with the server identifier contacts. This establishes a FastMCP application that will be identified as contacts in MCP protocol handshakes, allowing clients to recognize this specific server instance during communication setup. The string parameter serves solely as a label for identification purposes and doesn't configure any operational behavior.
Add app UI.
Applies the @app UI decorator to the function that follows, marking it as a user interface component in the FastMCP3 framework. This decorator integrates the function with the application's UI system, making it discoverable and manageable through the Model Context Protocol MCP interface. The decorated function will be exposed as part of the application's UI layer, with its name used as the default identifier unless explicitly overridden.
Def contact manager prefab app.
defines a function named Contact Manager that returns an instance of prefab app. The function signature indicates it will produce a prefab app object when called, though the implementation details aren't visible in this single line. The return type annotation, prefab app, explicitly declares the expected output type.
Add app tool. Def save contact name. SDR email. SDR dict.
Defines a tool function named SaveContact that takes two string parameters, name and email, and returns a dictionary. The app tool decorator registers this function as an MCP tool, exposing it via the model context protocol with the default tool name derived from the function name. The function signature declares the expected input types and return type, but doesn't show the implementation.
Hash option 1, providers list. MCP equals FastMCP platform. Providers equals app.
Creates a FastMCP instance named platform with a single provider specified by the app variable. The string platform serves as a server identifier visible in MCP protocol handshakes, while the provider's parameter explicitly registers the application as a service provider within this MCP context.
MCP equals FastMCP platform.
Creates an instance of FastMCP with the server identifier, platform, that will be used in MCP protocol handshakes for client identification. The string parameter serves as a label for the server, but doesn't configure functional behavior or operational mode.
MCP, add provider app.
Registers the FastMCP application instance, app, as a provider with the Model Context Protocol MCP instance, MCP. This establishes the application as a service provider within the MCP framework, making its capabilities available to other components in the system. The addProvider method is called on the MCP instance, passing the application object as the sole argument. FastMCP3's provider-based architecture shines through its flexible composition model, where FastMCP app instances encapsulate both UI entry points and backend tools into modular units. The framework offers two equivalent registration patterns: constructor injection via providers list or dynamic addition with add provider, demonstrating its adaptability to different initialization workflows. This modularity ensures clean separation between UI components marked with @app, UI, and backend tools defined by @appTool, with visibility rules that maintain stability across composition boundaries. The design's emphasis on maintainability becomes evident through features like automatic tool naming and namespace isolation, which prevent naming conflicts when multiple apps coexist on the same server. By abstracting tool references through call tool, the framework eliminates hard-coded dependencies, making applications more resilient to structural changes. The provider pattern ultimately simplifies dependency management, allowing apps to be added or removed without disrupting individual tool registrations, a critical advantage for scalable, distributed applications.
The decorator names tools that don't exist, while the server serves apps it never holds.